Hello, scholars, and welcome to Lesson 5, Session 3, on continuing to describe sequences of transformations involving dilation. So we've got a problem here we can jump right into. Let me get rid of these papers underneath here. We've got this shape, ABCD, and we are going to transform it into EFGH. This problem and a lot of them in here, I want you to take a moment and think about it. So I want you to take a moment and think about it. I want you to be able to tell me, how can I get ABCD onto EFGH with 3 or fewer transformations? I imagine you might be able to do it in 2, but go ahead and write that down once you figure that out. Pause, take a moment, think about that, and then write it down. So I see this spinning, right? If I rotate this around and spin it around, C is going to end up over here, right? It's going to end up here, and then if I dilate it, I am going to get our new shape. And I see right away that this is a dilation of 1/2. I don't know about you, but if I take this like side of 2 divided by a side of 4 right here, these correspond with one another, right? When I rotate it around, so 2 divided by 4, well, that's 1/2, right? Just divide 2 by 2, divide 4 by 2, and that equals 1/2. So what do I want to do? I want to rotate, rotate 180 degrees, whichever way, right? Clockwise or counterclockwise, it's going to put me in the same place. And then I want to dilate with a scale factor of 1/2. Now, there's other ways you could do this, right? We could reflect this over and then reflect it again. So reflect it over the x-axis, reflect it over the y-axis, and then dilate it down. We could do our dilation first as well, and we should end up in the exact same spot, right? Because if I dilate this shape first, it becomes this. And then if I spin that around or reflect and reflect it, I end up in the exact same place. So you're going to see that if we're dilating around the origin, like, it's not going to matter too much if you do your dilation first or if you do your other transformations first. We should usually still end up in the same spot. I'm skipping the next page and I'm going on to this page. Now, there's not a lot that I want to write down here. Like, you could write down your transformations that we use, but we already wrote that down. Does it matter whether it's dilated or rotated first? Either way works. Order didn't matter. We just need to be careful because sometimes order does matter, right? Especially when we're talking about doing rigid transformations in sequence. We need to be careful there. Is there another way? Yeah, we talked about reflections. We could have used reflections over the x and the y-axis. So yeah, I'm done with this page. Let's continue on to our last page then, our apply it section. So let's look at a couple more problems here together and see if we can help ourselves understand this better. So we're kind of thinking about this backwards, right? Our last lesson was showing us if I see them, can I identify them? Now this lesson's asking us, well, like, can you figure out how to get there? I'm not going to tell you, can you figure it out? So that's what we're going to try to accomplish with these last couple problems. like I said at the beginning, if you pause and try this on your own, I think you're going to get a much better learning experience out of this. So I'd actually ask you, would you pause for a few minutes here and try these two problems on your own, and then come back and see what I did? Because if you made a mistake, that's good. That's going to give you a really good learning process, and if you got it and made sense to you, you'll have more confidence that you really know what you're doing, right? So pause it, try it on your own. In the meantime, here's a random fact of the day. Did you know that cotton candy was invented by a dentist? Yeah, in the late 1800s, this dentist invented cotton candy. Some have suggested that he had an ulterior motive. And he wanted to make sure that kids kept coming back to get their cavities filled. So, uh, I think the guy was probably a jerk, but I guess he left us with cotton candy, which is pretty good. So, I don't know. How do you want to feel about it? Let's look at this problem now that you've tried it on your own. Triangle ABC is located at, and I'm going to graph this real quick so I can see it, 4, 8. That's A. 8, 0 is right here. That's B. And -8, -4. So -8, +4 is where C is. So, ooh, this is a big triangle, isn't it? And there is our triangle. Now, how do I get this here? Now, hopefully you've already thought about this. If you haven't, think about it first. But I want to see what I'm saying. Like, I definitely see a rotation here, yeah? That if I spin this around, A is going to be like here, B, and C. And B is going to come up here, right? So I'm gonna kind of sketch that for myself. Like if I rotate this, what is this? 90 degrees counterclockwise, going the way the clock does not go. There's 90 degrees. I was 8, 0. Now I'm at 0, 8. I was at 4, 8. Now I'm going to be at 8, 4. Oh, there's my new A. 8, 4. Now it's going to be down here at 4, 8. Like this would be that shape, right? I probably could have done the dilation first too, but I think this is what we're going to have. So I think I just need to find the one that says that, right? Side note, I love when you do this, okay? Think about the problem and solve the problem before you consider options, okay? Options are there to ruin you. Don't be ruined by the options. Do the thinking first and then look for your solution, okay? Because we might have gotten tricked by this clockwise thing. It's not clockwise. This is counterclockwise. Ooh, 90 degrees counterclockwise. And then dilated by a scale factor of 4. No, it would have gotten bigger if it would have been a scale factor of 4. What is the scale factor here? It was at 8. Now it's at 2. So image divided by pre-image. Image, I would write that down like every time so you don't mess that up. Image divided by pre-image. That's how we get scale factor. Image divided by pre-image. 2, that's from our image, divided by a pre-image. 8. I'm just taking a point, right? Because I can take a point, I can take a line length, I can take anything, and I am going to get my scale factor. Well, that reduces down to 1/4, doesn't it? This is getting smaller, so I should get a number that's less than 1. So it's not B. It's not 4. Rotated clockwise, we already said it's not rotated. Rotated 90 degrees counterclockwise. Dilation with a scale factor of 1/4. Boom! There it is. That is what we did. Let's try the next one. Pilar draws a rectangle, JKLM, in the coordinate plane. She performs 2 transformations on the rectangle JKLM to form rectangle J double prime K double prime L double prime M double prime. I immediately noticed something about this. Look, JKLM. J, K, L, M. The orientation is still the same. The orientation's still the same. So I'm immediately like, oh my goodness, there is no reflection or rotation. Because if it was reflected, these would be on the other side. If it was rotated, they would be like upside down. That's not happened, right? And I know that based on the letters and how they are oriented, right? So you might want to write that down. No reflection or rotation. But how do we get there? Well, I'm going to do my dilation first this time because it's going to help me see where I'm at. Look, this was 3. Our image was 3. Divided by the same length on our pre-image is 6. That reduces down to 1/2. So I need to make everything 1/2, right? Smaller. So this would like come into here, and this would come to here, and this, and this, and there's the shape, right? Exactly 1/2 smaller. So let's write that down. Dilation with a scale factor of 1/2. So now we're here. We've got J prime, K prime, L prime, M prime. Okay, so well, how do we get this up here? And you should figure that out before you see what I said. But we're moving it up. We're translating it, right? This just need to be copied and pasted up here. So K moves 1, 2, 3, 4, 5. L moves 1, 2, 3, 4, 5. This is a translation up 5 units. Ooh, I could write this like this too, couldn't I? That the x value stayed the same and the y value increased by 5. Okay, so could Pilar have performed the same 2 transformations in reverse order? If I would have moved this up 1, 2, 3, 4, 5, oh no. Oh no, we couldn't have, could we? Because this would have gone brrrr. We would have had to have translated it differently, at least, right? We would have had to move it up way higher than get it, then do our dilation. So, no, the translation, I think it would need doubled, right? Because we would need to get this up to like 8 to get it to, the translation would need doubled. We would need to move up 10 first, because then it gets sucked down, right? So it definitely would have mattered which order we did that in, or at least how we did that translation, right? It still could have been a translation, then dilation. But in this case, it looks like order matters. Well, if you have any questions, let me know. But I hope this was helpful, and you should know what to work on next. Thank you.